Hey, Harsh here. Today we are diving deep into one of the most critical decisions in system design: how to scale your system when it starts to grow. We will explore horizontal and vertical scaling with technical examples, real world case studies, and practical decision frameworks. By the end of this video, you will understand not just what these approaches are, but exactly when or how to use each one. Let's get technical. What scalability really means? It's not just about handling more users, we are scaling across three dimensions: load scaling for concurrent requests, data scaling for growing datasets, and compute scaling for processing complexity. The key is maintaining your performance metrics, like keeping response times under 200 milliseconds, even as demand grows exponentially. Vertical scaling means making one machine more powerful. You are upgrading from 2 CPU cores to 32, from 8 gigabytes of RAM to 5 and 2 gigabytes. On AWS, you can go from a tiny R6 1.large with 2 CPUs and 16 GB RAM all the way up to R6i.26x large with 96 CPUs and 768 gigabits of RAM. That's 48 times more powerful while your application code stays exactly the same. The biggest advantage? Your application doesn't need any changes. Database connections work the same, you maintain the same asset consistency without any additional complexity, and component communication happens in microseconds instead of milliseconds. When debugging at 3 am, you will appreciate having just one server and one log file to check. Here's where reality really hits. You're hitting the physical limits too. Moore's law is slowing down, and there is only so much power you can pump into one machine. Plus, when the super server fails, your entire system goes down. Horizontal scaling is distributed systems engineering. Instead of one powerful machine, you coordinate multiple servers with a load balancer directing the traffic. The key challenge is your application must be stateless. Any server should handle any request. User sessions go in external storage like Redis that all servers can access. This is where horizontal scaling shines. With n plus 1 redundancy, losing one server doesn't impact users. You can auto scale from one server to 1000 servers based on demand, use cheaper commodity hardware, and deploy globally for reduced latency. Netflix runs more than 1,000 microservices this way to serve their worldwide user base of 300 million subscribers. Here's the distributed systems tax you pay while scaling horizontally. CAP theorem forces you to make trade-offs in face of network partitions, and PaySelk extends that, asking, even when there is no partition, what do you want to give up? Latency or consistency? We will talk about all these complex terms in future upcoming videos. Network calls are not free. Within the same AZ or region, you might see a zero point 0.5 to 2 millisecond extra latency, and crossing these AZs or regions pushes up that further. Consistency model matters too. Eventual consistency works for many services, for example, caching, logging, some user information. But for billing, authentication, financial transactions, you often need stronger consistency. Again, we'll come to all of these terms in future videos. As number of services and servers increase, operational overhead rises sharply. This includes monitoring, tracing, deployment orchestration, rollbacks, version compatibility issues. So much to think about. And more servers is equal to more possible failure interaction. It's not just lose one equal to simple failure. It could be a cascading effect, partial failures, network partitions, timing issues. So much to think about. This decision matrix captures the core engineering trade-offs. Vertical gives you nanosecond latency but exponential costs. Horizontal gives you theoretically unlimited scale but requires distributed systems expertise. Your choice depends on specific constraints: team size, timeline, reliability requirements, and expected growth patterns. The decision really depends on your constraints. If you have a small team and a legacy app with tight deadlines, vertical scaling gives you immediate returns with lower risk. But if you are building a global platform that needs strong uptime, low latency worldwide, and you anticipate rapid growth, horizontal scaling becomes critical. In practice, many successful systems start vertically or use vertical for some components and then incorporate horizontal scaling as demand, scale, and complexity grows. For example, you might deploy web servers horizontally but keep vertically scaled database master, or use powerful instances for write heavy parts while using many small instances for stateless services. Netflix's scaling journey shows how you evolve from vertical to horizontal scale. In DVD era, things were simpler with traditional scaling. As streaming demand shot up, Netflix re-architected their adopted microservices, moved to AWS, enhanced fault tolerance and observability, and gradually shifted more responsibilities into distributed systems. Today, there are hundreds of microservices serving over 300 million users, stream tens of billions of hours of content per year, and use chaos engineering to surface failure modes. They scale up and scale down infrastructure based on viewing patterns and regional demand. You need good visibility before you can make scaling decisions. Tail latency metrics like 95th percentile and 99th percentile are essential because averages hide that really slow requests that degrade user experience. Throughput and resource usage tell you when systems are under strain. Correlate these with business metrics so you understand not just cost but value. For scaling triggers, a common pattern is scale out when CPU is 70 to 80% over a sustained period, or when tail latencies exceed the SLA or service level agreements. Scale in when users drops well below capacity but always with cooldowns to prevent bouncing. Choose tools that give you real-time and historical trend visibility. In early stages, vertical scaling trends to win because it is simpler and cheaper for single instance. But as load grows, you are paying more for capacity, redundancy, and handling spikes. Horizontal scaling brings that additional infrastructure cost but supports growth, reliability, and handles variable load better. Don't forget to factor in the cost of downtime, lost revenue, lost user trust, etc. Sometimes spending an extra few or $1,000 a month on redundancy or autoscale pays off massively if it avoids even a few hours of outage. Modern scaling is no longer manual. With reactive autoscaling systems to respond to metric breaches, though there is a time lag due to metric collection, container startup, readiness, etc., predictive or scheduled scaling helps mitigate that lag for known or forecastable load spikes. Kubernetes has built-in tools like HPA and Cluster Autoscaler, which require tuning, readiness, stabilization windows to avoid overshoot/crash. Serverless platforms like AWS Lambda can scale from zero to many thousands of executions quickly, but not always instantly for every function due to cold starts and concurrency limits. The goal is that elastic infrastructure that adapts to demand while balancing cost, latency, and reliability. This is your go-to scaling interview cheat sheet. Think of it as a structured way to quickly propose a scalable system depending on how many users you have and what kind of constraints you face. I will walk through how to use this in the interviews. So, for example, in small scale of less than 100,000 users, at this level, the simpler the better. Start vertical with one machine, database tuning, basic caching, and a CDN for static assets. You can get a lot of mileage by optimizing code, queries, and caching without introducing complexity. For medium scale applications, when traffic starts to grow, you need horizontal scaling for stateless parts. Introduce load balancers Multiple web servers, maybe read replicas for your database. Distributed cache to reduce database load. Also, auto-scaling groups to handle variation in traffic. And for large-scale applications, you need global/distributed design and a multi-region deployment with sharding or partitioning databases, microservices, and advanced caching strategies like edge caches, multi-level caches, tiered cache layers to reduce latency and avoid bottlenecks. This is kind of how you scale from a very small scale to large scale. In the future upcoming videos, I will bring you all these topics that felt too complex to process right now. Hope you understood what horizontal and vertical scaling means. Hey, if this video helped you understand this topic, don't forget to like and subscribe. You can also drop your suggestions down in the comments about the improvements and the topics you would like me to cover next. Till then, thanks for watching, and I will see you in the next one. Peace.